As per Newton's law of gravitation, any two masses in the universe exert a force on each other. This force is along the line joining the two masses, or rather the line joining the center of masses of the two masses. We are assuming the masses to be finite and point masses as of now. So the force exerted by mass 2 on mass 1 is written as F12, and the force exerted by mass, so this is mass 1 and this is mass 2. It has a value m1 and this has a value m2. So the force exerted by mass 1 on mass 2 is shown as F21. The distance between the two masses happens to be r. R12 cap is the unit vector from mass 1 to mass 2. So R12 cap is this unit vector and R21 cap is this unit vector. The force of gravity F12 can be written down as being minus G m1 m2 upon r square R21 cap, and it can be written down as G m1 m2 upon r cube into r21 vector. The minus n remains. Similarly, F21 can be written down as minus G m1 m2 upon r square r cap 12, so which is nothing but minus G m1 m2 upon r cube r12 vector, because r12 vector happens to be equal to magnitude of r12 into r12 cap. So magnitude of r12 is nothing but the distance between the two masses, which happens to be r. So that will get cancelled out with the denominator. So this r is nothing but magnitude of r21 vector happens to be r. Similarly, here magnitude of r12 vector happens to be equal to r. So essentially, so this is mathematically represented. So essentially, Newton's law of gravitation states that for any two objects m1 and m2 in the universe, there is a force of gravity that acts between them. So it is an attractive force. It is a conservative force. We'll see what it means when we define potential energy and understand what it conserves. So there is this force of gravity that is exerted between the two masses, which is attractive in nature, and both masses exert equal and opposite forces of gravity on each other. The force of gravity is given as G m1 m2 upon r square. Basically, the expression for the force happens to be G m1 m2 upon r square, or the magnitude of the force simply is G m1 m2 upon r square. Capital G is called as the universal gravitational constant. So the value of capital G happens to be equal to 6.67 into 10 raised to minus 11, and if you do a unit analysis, you will get the units to be Newton meter square upon kg square in the SI system. The dimensional formula for G is m minus 1 L cube T minus 2. This can be verified by the student. The value of G does not depend upon the size of the bodies, the nature of the bodies, the medium in between the bodies, the density of the medium in between the bodies, if there are other bodies in the surrounding, G is a universal gravitational constant. In fact, it is one of the most important constants of this universe. There are three primarily important constants. C, the velocity of light, which defines electromagnetism and the electromagnetic force. G, the universal gravitational constant, which defines the gravitational force. And H, the Planck's constant, which is in the quantum domain, which usually helps in understanding the strong and the weak nuclear forces. So these three constants define a lot about our universe, and G is one such constant. Now, the gravitational force between two objects is always attractive in nature. It does not depend upon the medium in between the particles. Like, for example, this medium could be filled with a liquid of density rho, or it could be filled with air, or it could be vacuum. The gravitational force does not change. Gravitational force, the gravitational force is a long range force, meaning even at distances that are extremely large, in the order of 10 raised to 10 meters, in the order of 10 raised to 15 meters, the gravitational force still interacts and still acts. The gravitational force follows the principle of superposition. So what does that mean? Let us say this is an object. So it has a mass m1. Let us say this object has a mass m2. Let us say this object has a mass m3. So the force on the mass 1, the net force will be the vector addition of the two forces. So this is F13, the force exerted on mass 1 because of 3. This is F12. So the principle of superposition says that the net gravitational force on M1 is nothing but the vector addition of F13 and F12. F13 being the gravitational force exerted on mass 1 by mass 3, and F12 being the gravitational force exerted on mass 1 by mass 2. So it follows the principle of superposition. So usually gravitational force will be relevant only when other forces are not acting, because gravitational force happens to be the weakest force. The nuclear force that binds the protons and neutrons together inside the nucleus of an atom is stronger than the electromagnetic force. And electromagnetic force is much stronger than the gravitational force. If we calculate, just to give you a perspective, if we calculate the electromagnetic force between two electrons, then we'll get the electromagnetic force to be equal to k E square upon R square. Now if we calculate the gravitational force between the two electrons, then F gravitational will be equal to G m square upon R square. Now if we take this ratio, F electromagnetic between two electrons divided by F gravitational, then the ratio comes to be in the order of 10 raised to 43. That means the gravitational force is 10 raised to minus 43 times the electromagnetic force, or the electromagnetic force is 10 raised to 43 times as strong as the gravitational force. So the electromagnetic force is extremely strong compared to the gravitational force. Now the gravitational force is a conservative force. Now what does that mean? The work done is path independent in taking an object from point A to point B. The work done by the gravitational force, let us say this is the path 1, let us say this is path 2, let us say this is path 3. So the work done in taking an object from point A to point B, the work done by the gravitational force is going to be independent of the path. So the work is going to define only on the starting point and the end point. So it is a state function and not a path function. Because of that, the gravitational force is said to be a conservative force. All conservative forces conserve the mechanical energy. So gravitational force also conserves the mechanical energy of the system. And potential energy can be defined for gravitational force. Since it is conservative in nature, we know that potential energy can be defined only for conservative forces. So the potential energy is defined as del U. Yes, it is defined as a difference. So only the difference of potential energy is significant, not the absolute value, because the reference point can always be changed. So it is defined as del U or du is equal to minus F dot dr. So it is negative of the work done by the gravitational force. So this F is nothing but the gravitational force. The gravitational force in between two objects obviously will exist as a action reaction pair. So let us say we have got two masses. So one mass, so this is mass m1, this is mass m2. So if the mass m1 is exerting, let us say, this force F, or rather mass m2 is exerting the force F on mass m1, then the mass m1 will exert a force exactly minus F on the mass m2. So gravitational force exists as a action reaction pair. Now if these two bodies are of a random shape, let us say, then the gravitational force will act through the center of gravity. The point through which the gravitational force acts, that point is called as the center of gravity. So this is center of gravity of the object 1, center of gravity of the object 2. Center of gravity is not exactly the same as center of mass. This is a point to note. Center of gravity is the same as center of mass only when we are talking about uniform gravitational fields. Otherwise, center of gravity may be slightly different from the center of mass. We'll elaborate upon this concept in some particular other lecture. Right now, it is just to be noted that center of gravity and center of mass may not be the same for non-uniform extended objects wherein gravitational force and field changes over the dimensions of the body. So these are a few points about Newton's law of gravitation and the gravitational force that we need to understand.